Good morning, everybody. We're going to start off this week by doing Unit 8, Lesson 3, and this is the square roots, functions, and shifting. So we're going to talk about, we did all of our quadratics in the last unit, and we just started talking about, square roots and simplifying square roots, and then we started talking about irrational numbers. So the next thing that we're going to be talking about is square root functions. So square roots are operations on numbers that give exactly one output for a given input. So they fit nicely into the definition of a function. We can graph the general square root function once we establish a very important fact about square roots. So we want to look at this example, the square root of -4. Why are neither 2 nor -2 the correct square root of -4? Well, when we're finding a square root, we're asking ourselves what number multiplied by itself is going to give us this number inside, right? So we're trying to figure out 2 times 2 is 4, not -4. And -2 times -2 is 4, not -4. So what can we conclude about taking square roots of negative numbers? Is there ever going to be a number that you multiply by itself and get a negative answer? There never ever will be, because when you multiply a number by itself, whether it's positive or negative, it's always a positive answer. So you're going to learn all about negative square roots in Algebra 2 and trigonometry and pre-calc. So what can we conclude? You cannot find the square root of a negative number. Okay? The reason why is because when we square positive or negative number, it's always going to be a positive answer. We'll never get a negative answer. So it's absolutely critical that you understand deep down inside why finding the square root of a negative number is not possible with any real number. So we're going to look at the basic square root graph, okay? So for exercise 2, we're looking at, this is a square root function, f of x equals the square root of x. So we're going to create a table of values that we can find rational square roots. So we can find the square root of 0, right? The square root of 0 is just 0. 0 times 0 is 0, right? We can also find the square root of 1. So the square root of 1 is 1, because 1 times 1 is 1. We can find the square root of 4, because 2 times 2 is 4, so the square root of 4 is 2. And then the next perfect square would be 9. We can take the square root of 9, and the answer is 3. So we're going to graph this function here. Okay, so real quick, let's label 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. 1, 2, 3, 4, 5, 6. Okay. First point is 0, 0, 1, 1, 4, 2, and then all the way to 9 and 3. So if we do this, what we see is that we get this shape that looks kind of almost like a mix between an exponential function and half of a quadratic function. So we're going to talk about that in a second. So what's the domain of this function? It's beginning at 0. Remember, domain is x values, right? Domain is from left to right. So we're starting at 0. Okay, and that's included. And it's going on forever. The arrow implies that it's going on forever, so that's going to be infinity. And remember, if we're doing infinity, that's a parentheses. So that's our domain. Another way you could write that is x is greater than or equal to 0. What's the range of this function? So what we're noticing here, the range, of course, remember, those are the y values. So we go from bottom to top when we look at the range. So it's starting at 0 again, and it's included. And even though it looks like it's not going to go too much further, we can't say that because there's an arrow. So we don't know how high up it's going to go. So it's still infinity. It's going on forever. And the other way to write that would be y is greater than or equal to 0. Okay? Circle the correct choice below that characterizes f of x is equal to the square root of x. Is f of x always decreasing or always increasing? So as you can see, it's always increasing. It's going up. So this is the correct choice. Now, what shape does the square root graph appear to be half of? And this is not a coincidence. So if you turn like this, it looks like it's half of a quadratic function. See that? And as Kirk says, it's not a coincidence. You're going to learn all about that when you talk about inverse functions in Algebra 2. There is a reason why this looks this way. Square roots and squaring are inverse function. They're inverse operations. So there's a thing called inverse functions, and you're going to learn all about them. It's actually kind of fun. And that's in Algebra 2 and Trig. So anyway, the shape appears to be, the graph appears to be half of a quadratic function. I'm going to put that in parentheses. I really should have written parabola. Half of a parabola, because that's the word we use to describe the graph of a quadratic function. So let's say parabola instead, okay? So now what we're going to do is we're going to look at how square root graphs are shifted. So we had a whole lesson on the shifted form of the parabolas when we did our quadratics unit. And the way that the square root graphs are shifted is very, very similar. So remember, when we're talking about them being shifted, all we're talking about is the graph moving around, up or down, left or right. So here we have the graph. This is y equals the square root of x right here, okay? So using our calculator, we're going to graph this function, see what happens. So I have the square root of x plus 4, and then outside the square root is plus 2, so you got to be super, super careful. So you're going to do square root of, which remember is second, and the x squared button, and now I'm going to put in x plus 4, and now outside of the square root I'm going to put the plus 2. So make sure you push that arrow, and make sure when you look it's not all under the square root, because that will change this completely. Okay, so now we're going to take a look. First, let's look at the table of values, because they are asking us for that. So second table, okay, and this is approximate, so why don't we we're only going to give the values that are not decimals here, okay? Because remember, it's a square root, so not every number is a perfect square, and that's why we have some decimals here. So I'm going to make a little table, but I'm only going to include the perfect squares, okay? So I can see -4, the square root of, -4 here is -4 plus 4 plus 2. That's why we have an answer. It's not the square root of -4. Okay, so that's 2. The next whole number value I get -3 and 3. I'm going to skip over -2 because that's a decimal, and -1. I'm going to go to 0 and 4. And let's see if we can find another whole number value somewhere. 5 and 5, perfect. And let's stop there. That's a good number. Now we're going to graph this. I'm going to show you what it looks like here, and then we're going to put it on our graph as well. Okay, that's not a very good picture. Let's do zoom fit. Okay, that's a little bit better. Still not the greatest picture to see what we need for the graph. What we really need is these points to see that. However, let's do a zoom standard, and that's much better. Okay, so what do you notice about the graph? It looks like it's been shifted to the left and up a little bit. So look at the original equation. Remember when we were shifting our quadratics, the number that was inside the parentheses, it made the graph move to the opposite direction that you thought. So if it was a plus, it moved to the left. Well, it appears that the same thing happened here. The graph moved to the left, and then the number that was outside of the parentheses was either up or down. So the plus made it go up. Same thing here, it looks like it went up. So why don't we use these points and actually graph them and see if that's really what happened. So we have -4 and 2, so -4 and 2. So again, let's see if we moved over 4. 1, 2, 3, 4, and up 2. So what we're hypothesizing here is correct. Then we have -3 and 3, 0 and 4, and then 5 and 5. Okay, and so and we can see it looks like our graph has shifted over and up. Now the domain and range of this new function here, we are beginning at the x value of -4 and we're going on to infinity. So that's going to be -4 to infinity, or for those of you who prefer it, x is greater than or equal to -4. And the range, bottom to top, so we're beginning at 2 and going up to infinity. So that will be 2 to infinity, or, okay, y is greater than or equal to 2. Okay, whichever way you prefer. Now we're going to look at a different function. This time it's x minus square root of x minus 1 minus 4. So let's predict what's going to happen based on what we know. We know that when we did shifting with quadratics, the number inside was the opposite of what you thought. So if it's minus, we always think left, so it's going to probably move to the right 1, and then this would tell us that it's going to go down 4. So let's see what happens. I'm going to go in here and I'm going to clear this out, and I'm going to enter a new one, so it's going to be second x squared, and this was x minus 1. And remember, push your arrow to get out of the square root and add that -4. If you don't push that arrow, the whole thing is going to go in there. So let's take a look at our table, and we're going to find some values. You'll notice that everything over here is going to say error, because those are all going to result in a negative number under the radical, which we can't have, we discussed before. So the first value I can have here is 1. Okay. So the first value will be 1, and the answer is -4. And then I can find 2, -3, 5, -2, and is that a 5 or a 4? No, it's a 5. 2, and let's see if we can find one more. 10 and -1. Okay, perfect. So we can plot these points and see if you have noticed. The first point here that we're looking at is representing the shift. So like I said, we're probably going to end up going right 1 and down 4. So let's see what happens. The first point is 1, -4. 1, -4. And there it is. Right 1, down 4. Just like we predicted. Then 2, -3. 5, -2. And 10, -1. Sorry. Okay, there we go. And connect. Whee! And there it is. Okay, so the domain of this one is going to be starting at 1 and going on into infinity, which can also be written as x is greater than or equal to 1. And my range is starting down here at -4 and going up to infinity. So that's -4 to infinity, or y is greater than or equal to -4. okay? So it looks like the shifting pattern we saw with the quadratics continues to hold with the square root functions. This pattern would in fact hold no matter what function we're looking at. So we're going to take a moment to look back at our friend, the absolute value function. Yes. So this is the graph of y equals the absolute value of x, okay? And we're going to take a look and see what happens if we add a number inside the absolute value and then subtract it. Before we do it, let's predict. So far what we've seen with the square roots and the quadratics was if you add or subtract a number inside the symbols, whether it was the square root or the parentheses that was being squared, in this case it's absolute value, then it does the opposite of what you think. So if it's plus 3, we're probably going to move to the left 3, and then the number outside does what you'd think. Minus 2 would be down 2. So let's take a look and see if that's actually what happens. If it is, it will go 1, 2, 3 to the left and down 2. So let's see if that's where it ends up landing. So in here, to get the absolute value symbol, you go to math and you move over to num for number, and ABS stands for absolute value. So just push enter and then you'll see your absolute value symbol. And now we're doing x plus 3 inside. To get out of the absolute value symbol, you use your arrow, and now you can do minus 2 on the outside. I'm sorry, my cats are being really crazy today. Okay, and now let's look at the graph. And sure enough, it did exactly what we thought. It went over to the left 3 and it went down 2. Okay, so we're going to state the domain and the range of this function. Were we supposed to actually graph that? I guess we were. So you know what, let me make a table. Sorry. Let's make a table real fast. Okay, we're going to need a few more values than we needed before. Okay, let's see if we can find absolute value. Where shall we start? Why don't we start, see if we can find, yes, there we go. An absolute value function also has somewhat of a turning point, like we learned about with parabolas, where they start to mirror themselves, right? So I'm going to try to find a few values on either side. So I'll start with negative 6. Okay, so negative 6 and 1, and then negative 5 and 0, and then negative 4 and negative 1, and then negative 3 and negative 2, and that's the turning point here. And now it's going to be negative 2 and negative 1. Everything mirrors now. Negative 1 and 0, and 0, sorry, and 1. And I'm writing that just because I know what it's going to be, but you can see it here. Okay? And I'll use this to graph. Sorry. Okay, use that to graph. When you create a table, you don't have to make it perfect, but I'm going to close it up. Okay, I'm going to graph these points. So it's negative 6 and 1. 1, 2, 3, 4, 5, 6, and 1. Negative 5 and 0. I went negative 1, sorry. Had a moment. Negative 5 and 0. Negative 4 and negative 1. And then negative 3 and negative 2, which is that point that I predicted before. Then negative 2 and negative 1. Negative 1 and 0. 0 and 1. And of course, this is just a few points. You can see that it's going to keep on going on and on and on and on. So the domain, we can't say a single x value. It's going on forever in both directions. So the domain goes from negative infinity to positive infinity. Okay? It's all of the real numbers. The range, however, begins down here at negative 2. And it goes up forever. Whoop. So that's y is greater than or equal to negative 2. Okay, if you wanted to write this using interval notation, you would do negative infinity is less than x is less than infinity. Excuse me. Okay, so let's see if we get the pattern. We're going to sketch this without the calculator. So inside is going to be the opposite of what we think. So minus 2 is actually going to be to the right 2. And then the minus 1 on the outside is going to be down 1. So I go here. I'm going to sketch it to the right 2 and down 1. So now I know I can see that the points are kind of going up and over. So from here I can kind of just sketch it like that. Okay? And it doesn't have to be perfect. When they tell you to sketch, it doesn't have to be perfect. Okay? And that's our sketcheroo. All right? Now, one thing I didn't do, I really should be labeling this. So this one was this one. The absolute value of x plus 3 minus 2. And this one here is y equals the absolute value of x minus 2 minus 1. Okay? And that's it, guys. So for the homework, all you really need to worry about is you're going to be using the square root functions, you know, plugging in a value to see what you get. But then you also are going to be looking at a graph and seeing which equation matches the graph, and also identifying like the range or the domain. Okay, so nothing too crazy today. All right, have fun with this.